Good afternoon all. Now in this lecture, let us talk about quality factor or Q factor. So what is quality factor? It measures the efficiency of energy stored in inductor or capacitor. It measures the energy stored in inductor or capacitor. It is defined as 2 pi times energy stored to energy loss per period. Energy lost per period means 1 by T, no? By T per period I say. Period, time period T, energy stored by energy lost. 1 by T is nothing but frequency. So 2 pi F energy stored by energy lost. So the value for energy stored is in inductor half L I naught square by energy lost through resistor is half I naught square R. So half I naught square cancels. 2 pi F what? Omega. L is there, here R. Okay, this we call it as Q factor. Similarly, in terms of this is in terms of inductor. Similarly, in terms of capacitor also we can write the Q factor as 1 by omega CR in terms of capacitor. Right? Now next, let us move for relationship between sharpness of resonance and Q factor. Right? Now let us draw the graph between angular frequency and voltage or current. Right? Maximum current. Graph comes out in such a way. Right? This is the maximum current E naught R. Now the sharpness of resonance is defined as, now this is the resonant frequency. You just see on either side of resonant frequency current is dropping. On either side, here current is maximum, but on either side of this resonant frequency current is falling down or dropping. This rapidity in falling of current from on either sides of resonant value with change in applied frequency, we call it as sharpness of resonance. It is nothing but the rapidity with which current falls on either side of resonant frequency. We call it as sharpness of resonance. Now this is how this is measured, means sharpness of resonance is measured as ratio of resonant frequency by difference in half power frequencies. Okay, so difference of half power frequencies at which the current falls to. Now these are half power frequencies. At these half power frequencies current falls to 1 by root 2 times the maximum current E naught by R. Half power frequencies, why we say? Here the current is falling to 1 by root 2 times the maximum current. So we call omega 1, omega 2 as half power frequencies. We call it as half power frequencies, right? And now this sharpness of resonance comes out as resonance omega naught by omega 2 minus omega 1 value will be equal to omega naught L by R. And this omega naught L by R what? Now only we find it, no, Q factor. So sharpness of resonance will be equivalent to the Q factor. Now let us find out bandwidth. So bandwidth means the difference between two half power frequencies. The difference between two half power frequencies, we call it as bandwidth. Right? And now let us calculate this bandwidth. So for that, now let us calculate what is F2 minus F1. So sharpness of resonance, it is omega naught by omega 2 minus omega 1. No, we can write it as 2 pi F naught by 2 pi F2 minus 2 pi F1. That is equal to F naught by F2 minus F1. But the sharpness of resonance what we got? That is equivalent to R by omega naught L, no? But what we want? We want to find out the bandwidth. That is equal to, now what we will write? F naught omega naught L by R. Okay? That is equal to F naught omega naught by R. So it is F naught by F2 minus F1. And the value of Q factor, sorry, I'm extremely sorry, omega naught by R. I'm sorry. So now bandwidth F2 minus F1 equal to R F naught by omega naught L. So F2 minus F1 equal to R F naught by 2 pi F naught L. F naught strikes off. Bandwidth value is R by 2 pi L. Now lastly, let us talk about power factor. Before defining power factor, let us define the small definitions through which only we will define the power factor. Right? So in that, first definition comes out to be instantaneous power. Right? It is the product of voltage and current. Next one, true power, or we also call it as active power, or we also call it as average power. It is defined as the rate at which energy leaves the circuit from resistive component. Energy leaves the circuit from resistive component, and mathematically it is written as current into voltage component E cos theta. So P equal to EI cos theta. Next, apparent power. It is defined as total voltage and total current, the product of voltage and current. Right? Now next, reactive power. Reactive power. It is defined as rate at which energy is alternately stored in and discharged from reactive components. One is energy will store. After storing, it discharged through the reactive components. It is denoted by Q and written as EI sin theta. Right? Next, power triangle. Okay. So, power triangle we will get geometrically. How we will construct means by using the equations of average, apparent and reactive power. Average, apparent and reactive power. How means? As usual, first let us take inductive load. Inductor. Here in inductor, current lags the voltage by certain angle. Current lags the voltage. Now what I am doing means I am dividing or resolving this current breaks into two components. One is along E, that is I cos theta. Other perpendicular to the E, that is I sin theta. Right? Now let us multiply this with E, voltage. E. We will get EI cos theta, EI sin theta. Now here EI sin theta what? Reactive power. EI cos theta what? Average or true power. Right? So here this is lagging. Right? This is lagging. EI sin theta is lagging behind EI cos theta. This is reactive power. This is average power. Right? And this is the angle theta. Now let us define power factor. Okay? So, power factor it is power is written as average power EI cos theta. In this, the cos theta we call it as power factor, the term cos theta. In P equal to EI cos theta, we call it as power factor. The angle theta is nothing but the angle between voltage and current. And this always lies between plus or minus 90 degrees. So, the power factor as well as power, they are always positive. Right? So, in inductive circuit, if we take, current lags the voltage. So, we have lagging power factor. And in capacitive circuit, current leads the voltage. So, we will have leading power factor. We have leading power factor. So, now what is the formula for power? So, power P is equal to ERMS into IRMS into power factor. We can write the complete formula for power as ERMS into IRMS into cos theta. So, this we call it as true power. And E into I, what we will call? Apparent power, product of voltage and current, into power factor. So, power factor is equal to ratio of true power to apparent power. So by this we completed the varying and alternating currents. Just note down all the formulas which I taught in this 3 to 4 video lectures regarding this varying and alternating currents. It will be very useful for doing the mathematical problems on this chapter. If you like my videos on varying and alternating currents for the preparation of MSc entrance classes, like it, subscribe it. Okay, thank you.